Hey everybody, today we're going to be talking about a little astrophotography, specifically how to track and photograph auroras. You've probably seen a lot of press lately and all over your social feeds, some of the amazing auroras we've done in 2024. It's one of the peak solar cycles right now. We're going to see a lot more action later in 2024. So I want you to be prepared on how to find the best spots for aurora photography. In this ultimate guide, I will go through what is an aurora, when we can find them, and how do we track them. Added to that, I'm going to go through some of the settings to get some of the best photography possible with whatever camera you have on hand and show you some tips and tricks on how to create those magical banger aurora shots that we're all looking for. This guide is cut up into 3 different sections. First up, we're going to explain all of the science behind what an aurora is. Second up, we're going to talk about the tracking, how to find the best locations and that kind of information. And third, we're going to get into the photography gear and settings. You can jump ahead to the different sections using the chapters below and go back and forth, find the different info that you may be looking for. So if you're looking to just skip ahead of the science and find out how do I track an aurora, you can find the links down below and get to the section that you're most curious about. So what is an aurora? An aurora is made up of charged particles emitting from the sun. That's electrons and protons that are getting emitted through what are called solar winds, and they're constantly hitting Earth. When those solar winds hit Earth, some of them just bounce away, and some get attracted to the poles. That magnetic energy there then creates what we see as an aurora. The Earth's magnetic field actually protects us from these energy waves, but sometimes they get attracted and directed to the poles. So North and South Pole, and that's where you get these geomagnetic storms and auroras emanating from the poles, and we get an aurora. When this energy interacts with the nitrogen and oxygen in Earth's atmosphere, it gets the atoms excited, and as that energy dissipates, that's how we get all the different aurora colors. Oxygen at over 150 miles in the air ends up red when it discharges that energy. That color is super rare, and so it's incredible. For example, on October 10th, when we got just the amazing display of red colors. Now at 150 meters and below, the oxygen ends up turning into a greenish color. At over 60 miles in the air, that nitrogen ends up being slightly purple. Below that, kind of a bluish hue. On October 10th of this year, we ended up getting just an amazing assortment of colors that came from both nitrogen and oxygen particles, all levels of the atmosphere getting charged up and then dissipating into those colors. So that's how you may see red on one day and green on another. It really depends how strong it is and where that energy is getting dissipated. So when can we see an aurora? As I mentioned, solar winds are constantly hitting Earth. So you may see any minor amount of aurora on any given day. But it's the really large, powerful auroras that we're interested in, as that's the easy ones to photograph, especially in North America at more southern latitudes. So the stronger the geomagnetic energy hitting the poles, the further south that aurora is visible. So to see an aurora, we're looking for 2 things. Either a solar flare. So a solar flare is a sudden and intense burst of energy and radiation from the sun's surface. This is caused by the release of magnetic energy stored in the sun's atmosphere. These flares occur when magnetic fields line up near sunspots, become tangled, and then snap, releasing energy in the form of light, heat, and charged particles. Solar flares release energy across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays. They can be powerful enough to emit more energy in a few minutes than a million volcanic eruptions on Earth. Flares can last from a few minutes to several hours, and their radiation reaches Earth in about 8 minutes, the time it takes for light to travel from the sun. Now, solar flares are one of the more common ways for you to see auroras on Earth, but they're not the most potent. Now, we're going to talk about coronal mass ejections. You ever heard of this term? Let me explain it to you. A coronal mass ejection, aka a CME, is a large expulsion of plasma and magnetic field from the sun's corona, which is the outermost part of the sun's atmosphere. During a CME, billions of charged particles, including electrons, protons, are hurled into space at high speeds, often traveling millions of miles per hour. CMEs are also a major source of auroras, northern and southern lights. As they enhance the interaction between solar wind particles and Earth atmospheres, it leads to brighter and more widespread auroras. It can take anywhere from 1 to 4 days for a CME to reach Earth. This is where you might see that an aurora is broadcast and expected to happen within the same day, versus a CME, which may mean we'll get a couple days notice for that aurora to potentially impact Earth. While both solar flares and CMEs originate from the sun and release energy, a solar flare is an intense burst of radiation, whereas a CME is a massive release of charged particles. CMEs are typically larger and can have more significant impacts on Earth's magnetic fields. Long story short, we want these events to happen so that we can get some of these epic auroras. So how do we track all of this? How to track auroras. Many apps and websites actually issue alerts on when an aurora is going to happen. Now, one of my favorite apps and websites to use is actually the NOAA's website. First up, the Space Weather Prediction Center by the National Oceanic and Atmospheric Administration, NOAA. They have a tonight and tomorrow prediction, as well as other tools to gauge current or potential geomagnetic activity, and thus likely an aurora. Most tools use this physical attribute of a KP index to relay aurora info to your average user. Wait, what is a KP index? Well, the KP number, or KP index, is a scale used to measure geomagnetic activity in the Earth's magnetic field. It is commonly used to track disturbances caused by solar wind and solar storms, and is a key indicator for predicting auroras. Some of the key aspects of the KP number is it ranges from 0 to 9. When you see a 0 to 2, it's low geomagnetic activity with a minimal chance of auroras outside of the north or southern poles. 3 to 4 strength, moderate geomagnetic activity, and auroras might be visible at higher latitudes. 5 and above, this is when we're actually genuinely interested in most of North America. This means a strong geomagnetic storm with a KP of 5 or higher indicates the potential for widespread auroras. Now, on May 10th and October 10th of this year, it was somewhere between a 7 and a 9, which you saw the aurora as far south as Florida, which is insane. So it is possible to get these auroras to go very far south, but we're going to need somewhere between a 7 and 9 of KP strength. You might also see something called a GM number. Now, when a KP is 5 or above, it is considered a geomagnetic storm, which can lead to auroras being visible at lower latitudes. KP 7 and 9 represents severe geomagnetic storms, often allowing auroras to be seen in areas much farther south from the pole, such as the northern US or southern UK. How is it measured? Well, the KP index is calculated by measuring fluctuation in Earth's magnetic field at multiple observatories around the world. The number is updated every 3 hours, reflecting real-time geomagnetic conditions. That said, when you see KP readings with future time and dates, it's more so a prediction than an actual reading, as it hasn't occurred yet. Outside of the KP scale, you might see reference to the GM 1 to 5 scale, which is NOAA's way of giving a severity scale to geomagnetic storms, similar to how hurricanes and tornadoes are categorized. GM activity is a really easy way to track if a geomagnetic storm is coming and it's worth chasing the aurora. On May 10th and October 10th, it was something like a GM3 to GM4, which was a sign that here in Toronto, we should probably try to drive up north to get some auroras. Now, it was seen again pretty far into the US, so it is possible if you're away from the city to get an aurora. So you don't necessarily have to drive far north to get them. These KP and GM numbers are just a method for you to know if it's worth trying to venture out to look for an aurora. Just because there's maybe a GM3 or a GM4, it doesn't mean that you're necessarily going to see it at southern latitudes. It's not a geographic number as it is an average of how far south it can go. So you can get something like a GM3 on 2 separate days and not see it geographically as far south as the other one. Because auroras happen so far up in the atmosphere, it's actually possible to see it a little further than its actual center. So an aurora can happen, for example, over Toronto, and you could see it up to a couple hundred kilometers south of where it's actually occurring overhead. So something to keep in mind if you're ever tracking it on an app is that it may appear further south than it actually is, in which case you'll see it along the horizon rather than overhead. So keep that in mind. Now that we know what we're looking for, what app do you recommend? Now, looking at the same day and next day forecast on the NOAA website is a great tool to be able to forecast in the next day or so if it's going to occur. But what if you're just looking for the easy route? Well, there are a couple apps available that actually allow you to get a push notification to your phone. There's a countless supply of Aurora apps out there, but one of my personal favorites is the free app Aurora. It's available on iOS and on Android, and you can set the different KP strength for it to push notification to your phone. Out of Toronto, I have it set to notify me of anything KP6 or higher. Now, it doesn't mean on any KP6 I'm going to leave the house. More in reality, I'm looking for 7 and above, but it's just handy to keep that number in your mind, and then you can do some secondary research. Now, in that app, there's actually a way to check webcams, in which case I, being in Toronto, can check webcams for Scandinavia and some of the more easterly areas and see if you can actually see an aurora. That's a good indicator of the future, so to speak, where we can see, hey, it's an aurora, pretty potent, and will it end up coming our way? So we've covered what an aurora is, what causes them, how to track them, and now you're probably wondering, what's the best place for me locally to actually find them? Well, here are some tips that I find useful. First up, the auroras on any given day, if you're near the north and south latitudes, so near the poles, that's where you're going to end up seeing it consistently. I've been to Iceland when it's been a KP2 to 4, and I've seen them right overhead. So instead of more north latitude, it's in the prime time zone. That's a great place to be. Now, if you want to talk a little more locally, if you're someone, say, in the middle of Toronto, where do you go to ideally see the northern lights? Toronto has a lot of light pollution. Now, light pollution basically is all the city lights that are emanating out. Now, as light pollution is impacting the area around us, it makes it harder to see other lights, especially fainter ones. So that said, you want to get away from those lights. There are light pollution maps online where you can see what are bright and dark areas around the world. I'm going to show you here around Toronto. You can see as we go northeast and northwest from the city, there's a lot darker area. This is typically around farmland, forests, lakes, where there's no city lights or just general urban dwellings that are emanating light out. These are prime spots for you to go and watch the aurora. You may also around your area have something like a dark light preserve. There is one here in Ontario called Torrens Barrens. These dark sky preserves basically are trying to do, as they say, preserve the darkness. So you can go to these areas. They may be pretty popular, which is a little bit of a downside, but going to an area like that makes it easier to spot different auroras, comets, meteorites, and that kind of thing on any given day without having to worry about too much light. So from Toronto, I like to go somewhere like Caledon, even maybe up to Collingwood, which can be brighter as a city, but it's over the lake and it's far enough north from the major city of Toronto where the light pollution's less, and there's lots of area over the lake where you can still see the northern lights. For example, I got this shot here on October 10th, looking over the lake. There was lots of cars, light pollution, that kind of thing, but the aurora was so strong that it made for a great scene. If we're going east of Toronto, there's a lot of different farmland and smaller towns where you can go there and just watch the aurora from those regions. There's no specific spot you're looking for, but, a side road that is going into farm regions usually is a pretty safe bet. For those of you photographers looking for something interesting, you might want to get a little more creative. We're looking for different foregrounds, maybe a lighthouse, an old building, or something like that to basically get a slightly better photo. Now, I'm going to leave that up to you to find the best location, as if I say a certain spot, it's probably going to lead to too many people going there. So, sorry about that, but best of luck. But basically, you're just looking for dark areas with interesting things to be able to get a great view or great shot. Another important, and I can't stress this enough, important point is for you to check the weather. Now, cloudy weather can really ruin an aurora. So back in May, when we were trying to chase the aurora, we were really looking at where the clouds were going to be. We saw that in the west, they were going to be coming out, loosely trying to time it. We tried to go in an area where it would be long enough before the clouds hit, so we can witness the aurora before the clouds took over the region. So that might make a difference between if you're going to drive northeast of the city or northwest, try to find a dark spot. On October 10th, across Canada, there were a lot of areas that were just completely clouded over. So it was very important to check what was an important place to go. You may remember when the eclipse was happening, it was the same kind of issue. Where can we go to be able to see the eclipse where the cloud cover is not going to be there? That's where you can use any weather app, change to the cloud overlay, and do your best job of trying to track if the cloud's going to be there. Some of the apps I like to use are honestly just AccuWeather, Storm Radar, or even Clear Outside. These apps are all free, and these apps help me try to identify which areas are going to be a little cloudy so that I can try to aim for a great clear sky. So in summary, get away from the city, away from light pollution, find a dark place, away from city lights, and make sure there are no clouds in the sky. Next up, let's talk about how to photograph the aurora. We're going to need gear, so let's jump into that first. Any camera can work. This means your iPhone can work great, iOS, whatever you have, they all work great these days. You can just hold the phone up and get amazing photos. The key is you need to be steady. So if you're a phone user out there, try to get a mobile tripod and keep that in mind when you're photographing. Now, if you're someone like me and you have a camera, again, it could be a DSLR, it could be an older camera, newer camera, it doesn't matter. I have a Canon RF and RF II, and I've shot them fantastically with that, but I've also used my old T1i and 7D, which are 10 plus years old, to capture an aurora. All the difference is going to be is the more fancy your camera is, probably the easier time you're going to have on focusing and getting better light quality. As far as the gear you're going to want to have with this, number one, tripod. You need to have a tripod because you're going to need to take some longer exposures potentially, and that means you do not want camera shake. If you don't have a tripod, try to put the camera down on something, car, rock, bag, whatever you can, so that there is no movement on the camera when you're taking the photo. Second thing I suggest is getting a remote shutter. Now, I have a camera release shutter. I have a wireless version that actually just attaches to the hot shoe, plugs into the camera, and allows me to use a remote trigger to fire off photos. I originally bought this for the solar eclipse. It ended up being cloudy, which is another story completely, but I have this trigger now that I take with me in scenarios like this. They don't have to be too expensive. I think I paid around $40 for the one I have. I'll put a link down below if you're curious about getting one of these. This one I've used and it's pretty handy. A couple of us have it and honestly it works great. If you do not want to invest or you don't have the budget to grab one of these, what you can actually do is set up a timer on your camera. They all have the ability to have something like 3, 5, or 10-second delays before shooting, and that's handy to be able to hit the shutter or back screen, let the camera settle, and shoot without you actually having to touch it. That means it's less likely to have any camera shake. My last gear tip is to get a wide angle lens. I have a 15 to 35 millimeter on a full frame camera. If you're shooting crop, just keep in mind that there's a multiplier factor. So if you have something like an 11 millimeter on a Canon camera crop sensor, it's shooting closer to 16 millimeter. All the math aside, basically shooting wide allows you the best opportunity to capture whatever's going on in the night sky. Whether that's shooting stars or an aurora, shooting wide really helps you capture as much as possible. Next up, the lens ideally should try to shoot wide open. What I mean by that is something like f2.8 for your aperture. f4 can work as well, but obviously 2.8 lets in more light. So the wider the aperture, the more light it's going to let in, and it's going to make your life easier when shooting astro. Last but not least, what settings do you need to shoot an aurora? Just like any astro photo, an aurora really can range on some of the settings that you need to shoot with. There are some base settings I'm going to suggest, but you really might need to adjust depending on the scene you're in, how dark it is, and what's going on in the sky. For something like an Aurora, I like to start at f2.8, ISO 1600, and a shutter speed of about 2 seconds. From there, you can adjust. If the scene's a little too dark, we can up our ISO to 3200. And I want you to keep in mind that these days with something like Lightroom or using an app like Topaz, you can denoise your photos. So going up to 3200 will not ruin your shot. It's better to have a more neutral, brighter composition than something that's too dark and as you're editing it, just doesn't have enough shadow detail for you to edit. If you're shooting something like the Aurora and it's 30-second long, if there's a lot of movement in the sky, you might get some of the details, like the columns, get a little smudged and blurry looking on your photo. So although a really dark scene, you can shoot 30 seconds and maybe get a little bit of a brighter shot, it's not something you should rely on every time. So on October 10th and May 10th, I was shooting somewhere between 1 second to 2 seconds, which was enough to capture a good amount of light, but wasn't too long that I was losing some of the detail in the movement of the Aurora. So what I'm talking about is these areas here where there's a little bit of a ripple or column effect in the Aurora. And if it's very active, the longer the exposure, the more likely that's gonna look like a blended kind of blurry blob. So if there's not a lot of movement, you can take a longer exposure and it's not gonna ruin your photo. So this is where you're gonna have to gauge the scene and change your settings as you go. It is important also to set your white balance, especially if you're shooting intervals. I like to shoot at Kelvin 5200 just to have something consistent. I mean, you can pick 3700, it's irrelevant. You can edit that color white balance in Lightroom after the fact, but if you're shooting intervals, you don't want the camera to meter and change your white balance as you go, as it's going to make your life really difficult to stitch all those photos together. Next up, we're going to want to avoid autofocus. When it is too dark of a scene, it doesn't matter what camera you have, it's probably going to struggle a little bit with focusing on what's going on, especially if you're shooting up at the sky and it doesn't have enough contrast to pick up what the object is. Whenever you're shooting astro, we're going to set to manual focus. Try to pick out a star or an object you want in focus. Focus on it and digitally zoom in and try to get a pinpoint sharp star. If it's in the dark, what you can also do is tape the focus there. So if you're handling your camera, you don't accidentally lose your focus. The only other tip I can give you, again, is to try to get interesting compositions. First time you see an Aurora, the thought is probably to just shoot the Aurora. If it's right overhead, that actually isn't a horrible idea, as this time lapse here was shooting straight ahead. And the Aurora, when it's coming at you, can be a gorgeous thing. But you can really add to that by getting a little touch of tree line in the frame to add scale to what you're doing. Perhaps a silhouette of a person in the foreground, and you can get creative that way. Otherwise, if we have more of a landscape shot, look for interesting objects or structures, put into your foreground to really make your photos stand out. This is where location scouting ahead of time, you see something interesting in a cool area, pin it on your maps so you can go there at moment's notice and you don't have to plan too far ahead. So I've had locations like lighthouses pinned on Google, and when interesting astro events come up, I'm ready to go. Tonight we're actually going to shoot the comet, and I have it pinned in a location where I can get it above an old malting silo. So this is where planning ahead for the event helps you shut off your brain and just go and not miss the moment without sitting there trying to plan too much. And there you have it. This is how you yourself can go out, find Aurora, track it, get to a great spot, and take an amazing photo. If you have any questions or you want any details about any specifics, leave a comment down below. If you like this video, give it a thumbs up. Subscribe for more tip videos and different camera-related content. I hope you enjoyed the video, learned something new, share it with your friends, and I look forward to seeing your shots out there. If you got a great photo, I'd love to see it, so don't be shy to reach out. And until next time, I hope you get some amazing skies.